Space Coffee, presented by Science at NASA. Astronauts on the International Space Station give up many pleasures to take those giant leaps in the name of science. They leave behind fresh vegetables, relaxing hot showers, warm sunshine, gently misting rain, and much more. One of the things astronauts say they miss most is a good cup of coffee. How would you like to start your morning sucking freeze-dried coffee through a straw from a sealed plastic bag? Good news for astronauts. Morning Joe recently got an upgrade. On April 20th, SpaceX delivered to the space station a new microgravity coffee machine named Espresso. Our aerospace engineers have designed a coffee maker that can function in microgravity conditions, says David Avino of the Italian engineering firm Argotec. Working together with the coffee company Lavazza and the Italian Space Agency, we have brought authentic Italian espresso onto the International Space Station. No one wants to drink Italian espresso from a plastic bag, however. What astronauts need is a zero-G coffee cup. Fortunately, 6 of these wonders have been delivered to the space station as well. Fluid physicist Mark Weislogel of Portland State University and IRPI LLC, who helped invent the cups, explains why they are necessary. If you try to use a regular coffee mug, you might not get the coffee to your face, says Weislogel. It would be trapped at the bottom of the mug. In low-gravity environments like the space station, fluids tend to get sticky. Surface tension and capillary effects, which are overwhelmed by gravity on Earth, rule the day in space. As a result, coffee tends to cling to the walls of the cup. You could dip your tongue in the cup and lick the hot coffee out, or you could throw it out of the cup and suck down the scalding blob that forms in the air. No thanks. The zero-G coffee cup solves these problems by going with the flow, putting the strange behavior of fluid in microgravity to work. Basically, explains Weislogel, the liquid piles up right at the lip of the cup and keeps flowing as you sip. It pours out by the combined effects of your mouth, the wetting conditions of the fluid, surface tension, and the particular shape of the cup. This oddball cup wouldn't work on Earth, but it is a marvel in space. Weislogel and colleagues learned how to make the coffee cup by conducting capillary flow experiments on board the station. For years, they've been studying how fluids on the station climb the walls of their containers, turn corners, and perform other maneuvers that defy earthly intuition. It's not all about the coffee, he says. We need to understand how fluids behave in any container. The operation of many critical space station systems, air conditioning, refrigerators, toilets, cryogenic fuel tanks, medical treatments, the water supply, and everything else that involves liquids, depends on the ebb and flow of fluids. These systems must work without gravity if they're to be used on the International Space Station or on a spaceship en route to Mars, he adds. Compared to those other systems, coffee is not in the critical path of operation, says Weislogel. Try telling that to the astronauts about 5:30 tomorrow morning. For updates from the International Space Station, go to www.nasa.gov/station. And for more eye-opening science news, stay tuned to science.nasa.gov.